All right, folks, so we are starting at the bottom of page 4 in your notes. And the first thing we want to do is identify that A is a non-monic because there is a 2 in front of our x squared. Now, sometimes you'll be able to take out that number as a GCF. Can I factor out 2 from 11 and 6? From 6, yes. From 11, no. So I am stuck with this A value. So this is where the X method comes into play. So X method. So for the X method, instead of just looking for a product of the last term and a sum of the middle term, we're also going to be looking for a product of the first term. In all the factoring ones that we did yesterday, it was always x and x in the two numbers, or x and x in the other two numbers. But once I have something other than 1 here, such as what we have with this 2, I'm going to need to have 1x and 2x in order to be able to get the FOILing to work out. So as soon as I change the coefficient in front of x squared, it's going to affect the whole FOILing and factoring for the problem. So folks, let's go ahead and start with listing our possible factors of 2. I'm going to go through this fairly slowly the first time so you can get the hang of how we set this up. So we are going to actually write out 2 potential factors of 2x squared, which would be 1x times 2x would give us 2x squared. Then we're going to look at our other product number, the 6, and we're going to list out 2 possible factors for that one, such as 2 and 3. Now, if you're looking at that going, but Mrs. Cairo, it's a -6. We're actually not going to worry about the sign of that product until we figure out what our sum should be. So this is how we set up the X method. We list potential factors for the first term that will give me that product, potential factors for the last term that will give me this product, and then the reason why it's called the X method is we crisscross multiply. So I'm going to take 1x times 3 to give me 3x, and 2x times 2 to give me 4x. And what we want to see with these terms that we just got is it possible for a combo of these, either negative and positive, to add up to give me -11? If I make them both positive, positive 7x. If I make them both negative, negative 7x. One positive, one negative, 1x or negative 1x. Any way for me to get -11? Nope. So those are out, and these are out as potential pairs. And this is nice because we put a single line through them to show we have tried those things. Again, we're going to have to do a bit more kind of guessing and checking here, but this helps me keep track of what I have already tried. Next, we'll try 3 and 2. Is switching the order going to give us different numbers? Yep. So 1x times 2 is 2x, and 2x times 3 is 6x. Are these two numbers able to give me -11x? That's a no as well. So what else can we try for factors of 6? 6 and 1. And as we start doing more of these, you'll kind of be able to think ahead and say, if I do 2x times 6, that will get 12, which is pretty close to 11. So I'm going to go ahead and stack the 6 on the top and the 1 on the bottom. So how much work you have to show on these will depend on what you try first, if you get lucky, and if you can kind of look ahead and see what numbers will solve the puzzle most efficiently. So let's go ahead and multiply on the x. 1x times 1 is 1x. 2x times 6 is 12x. Now, if I need to get a sum of -11, who needs to be negative here? The 12x. So I'm going to put a negative here, And then we adjust the signs of the right numbers. So only adjust right numbers signs. So if I need this to be a negative 12x, who am I going to have be negative? The 6 or the 1? The 6. So that 2x times negative 6 will give me negative 12. And after you adjust the signs, we have to check to see that those do give me the right product number. So is negative 6 times 1 negative 6? So at this point, we have found what works. But now we need to figure out how we're going to turn all this junk into something times something else, or how we write the two factors. Before we do that, actually no, we'll do this first. The only thing that makes the X method kind of complicated is how we write the factors, because though we multiply these two terms together, the terms that go in the parentheses together are straight across from each other. So the 1x gets paired with the negative 6 in a parenthesis. So x minus 6 or 1x minus 6. And then the 2x gets paired with the 1. And that is my factored form. A lot of times students don't love that because it's like, wait, why are we putting the ones that we weren't multiplying in the same parentheses? I'm going to show you why, and it goes back to what we've already done with FOILing. If I take first times first, x times 2x is 2x squared. As you can see, these two product numbers that we started with gave me the f part of FOILing. 1x times 2x, 1x times 2x. If I do my outside product, x times 1 is 1x. And now I see that this part of the x method gave me the O part of FOILing. If I do my inside product, negative 6 times 2x is negative 12x. So this term gives me the I part of FOILing, and negative 6 times 1 for the L part of FOILing is negative 6, which is these two terms over here. So the X method has within it all of the components of FOILing. That's why it works as a way of working backwards or factoring. So if I think about FOILing, do I ever multiply the terms that are in the same parentheses together? No, I never multiply the X and the 6. So I do multiply those together. I do multiply on the crisscross together, but since I never multiply the X and the negative 6 together, that's why they end up in the same parentheses together for a factored form. What a mess, right? Right. Now, we're not going to do the FOILing on every problem. We're not going to do these labels on every problem, but some of these will require a bit more work. If you go, I hated that, I don't expect you to feel good about this. This is the first time you've seen this, and we're going to continue to do a whole mess of work with factoring. This is pretty much all we're doing today is just more factoring. So this is the first time we've seen the X method. Now we're going to jump into problem B. So first, I check for a GCF. Is there any way I can take that 3 out?
1, 3.
So we can't divide it away, so we're stuck with this A value, which means we're going to have to use the X method. So X method is for when we have A values that aren't 1 or non-monics. So we start with looking for a product of 10, a sum of negative 17. That's the same as it was with normal factoring, but now we also need to get a product of 3x squared. So this is now getting involved in the whole factoring process. So we start with the 3x squared. What are two items that give me a product of 3x squared? 1 and 3, so 1x and 3x. What are two numbers that give me a product of 10? 5 and 2. Which one do you want to stack on the top? The 5. Can you explain why? Bigger number, that's giving me 15 when I multiply on the x. So some problems you might have to try a lot of different pairs. Other problems you might be able to kind of predict what might work. So product, and now we multiply in an x shape. So 1x times 2 gives me 2x. So this times that. Then I do the other side of the x. 3x times 5. 15x. Is there any combination of these terms, positive or negative, that will give me the sum of negative 17 that we want? What are we going to need to do with both signs? Both have to be negative. So if I need both of these to be negative, that means I'm going to need to adjust both of these numbers to be negative. We never adjust the signs of the first two terms, only the terms on the right side. And then we check ourselves. Is negative 5 times negative 2 equal to positive 10? Sure is. So we have effectively found the numbers that work. Now we need to write them as factors. To write the factors, we go straight across the x. We put the numbers together that we don't multiply. The x with the negative 5 and the 3x with the negative 2. So x minus 5 and 3x minus 2. And there's our factored form. Now, what if I had 3x minus 2 and x minus 5? Is that the same factorization?
Yes.
Yep. What if I had 3x minus 5 and x minus 2?
No.
No. And if you're like, well, why wouldn't that work? If I FOIL this, I do get 3x squared, but then I get negative 6x and negative 5x, which is negative 11x for the middle term instead of negative 17x. So, folks, the reason why I'm showing this to you is to warn you to be very careful when you are checking on the answer key. You can have the factors themselves flipped around, but the stuff inside the parentheses has to be exact. Okay? Let's go ahead and take a look at problem C. Is there a GCF or something I can take out of everybody?
4.
Ooh, can't divide 26 by 4, unfortunately, but we can take a 2 out. So I can't completely factor out the A value, but I can take out a 2. And folks, this is very useful because 12 has quite a few different pairs of factors. But if I take out a GCF of 2, that makes all of the numbers smaller, which means less combos for us to try. 6 has far less factors than 12 does, so it makes the whole factoring process easier. So that's why we always check for a GCF first. Now from here, since I do have a coefficient of x squared, we're going to have to factor this using the x method. Folks, I want you to grapple with this for 1 minute. Give it a shot. If you want to know what the technical definition of grapple is, to engage in a close fight or struggle without weapons, to wrestle. So grapple with the problem, you're going to battle with it. So we start with looking for a product of 2x squared. 1x and 2x is the only pair that will work. And if you're like, I have it as 2x over 1x, does it matter? No, because how the x method works out, you will end up getting the same parenthetical terms. So then how about 6? What did you start with? 2 and 3, 3 and 2, 6 and 1, 1 and 6. So if we do 2 and 3, that gives me 3x, multiplying on the x, and 4x. Is there any combo of those, positive or negative, that will get me up to 13x for a sum? That's a no. Then I tried 3 and 2. 2x. 6x. Yeah, that's a no too. And again, I don't recommend erasing your work. I know for some perfectionists, it's a little unsettling just to be like crossing those things off. But as we get into bigger numbers that have lots of different pairs, you are going to want to make sure that you're keeping track of the ones you have already tried. So folks, let's go ahead and move to 6 and 1. Now I'm going to stack the 6 on the top because 2 times 6 will get me close to 12, which is close to 13. So 6 and 1. So 1x times 1 is 1x. 2x times 6 is 12x. Now, do I need to adjust the signs at all to get a sum of 13x? We don't. But even though we haven't messed around with the signs, we still have to check and make sure that we're getting the right product number. Is positive 1 times 6 positive 6? Yes. So, how are we going to write our factors? The 1x gets paired with the positive 6, so x plus 6. And the 2x gets paired with the positive 1, so 2x plus 1. X plus 6, 2x plus 1. And it's wrong. What? It's not that it's wrong, it's missing something. Anybody see what we're missing from this factorization?
2.
The 2! And if you're like, do we really care about that 2, Ms. Carver? We do, because we need to make sure we're not changing the value of the original expression. If I don't have that 2 there, and I FOIL this sucker out, I'm not going to get the original quadratic that I started with. So anytime you factor out a GCF, make sure you bring it down all the way with your factorization. There we go. So GCF. Pew. Remember to take it out. Remember to bring it down. If you don't remember to take out the GCF from the get-go, you might end up with something like this. You might end up with something like 2x plus 12 over 2x plus 1. So let's say that you didn't take out that 2, and you did this factorization to get 2x and 2x to give you the 4x squared. Folks, is this completely factored? No. So if you don't take out the GCF at the beginning, you'll have to take out a GCF. Whoops, you guys can't see that. You'll have to take out a GCF at the end to factor it fully. So always take it out in the beginning, because this is going to make the X method easier for you. It's going to make your number smaller, and that way you won't have to try to remember to do it when you get to the end of the problem. Folks, we're going to go ahead and we're going to go into the guided practice next.